the work transfer is given by P1 V1 minus P2 V2 by n minus 1. Can anyone give me what is polytropic heat transfer? याद है आपको? Polytropic heat transfer is given by, बोलो एक बार, gamma minus n by gamma minus 1 into work. These are the equations that I gave for a closed system undergoing different processes. Now let us start with a wonderful question. Let us start with a wonderful question, my dear students. Let us start with a wonderful question. Please read the question. Please read the question. अब time waste ना करेंगे, time waste नहीं करेंगे. Please read the question. A sealed. Can anyone tell the meaning? Every word has a meaning. Sealed, closed, rigid, constant volume. Has a volume of 2 meter cube. देखो एक बार. There is a container. Its volume is 2 meter cube. Okay. Contains a liquid vapor mixture at 10 degrees centigrade. So there is a liquid vapor mixture. There is a liquid vapor mixture at 10 degrees centigrade. The vessel is now heated to a final temperature of 50 degrees centigrade, and the initial temperature is 10 degrees centigrade. Wonderful, my dear students. And today I started SOM, and it was awesome experience, my dear students. Okay, the vessel is heated. The process stops until the liquid phase just dekho, read the question carefully. The process stops when the liquid phase just disappears. The process stops when the liquid पहले क्या था, ध्यान से सुनो. Let me represent it on PV diagram. Initially there is a liquid vapor mixture. तो ध्यान से सुनो. Finally क्या बोला है वो? The process stops when the liquid phase just disappears. When the liquid phase is just disappearing, means it is reaching saturated vapor. Wonderful, my dear students. This is the final state and this is the initial state. Wonderful, my dear students. Can anyone tell me why are you showing by a vertical line? Because it is a PV plot, so it is isochoric, rigid container, constant volume process, rigid container, constant volume process. So therefore, this is the process, this is the process. And this temperature is given as 10 degrees centigrade. Sorry, the final temperature is 50 degrees centigrade and the initial temperature is 10 degrees centigrade. पूछ क्या रहा है देखो एक बार. Okay, everything is given. The initial mass of the liquid. Matlab, initially there was a liquid vapor mixture. It is heated from 10 degrees centigrade to 50 degrees centigrade. So he is asking what is the final, what is the liquid in the initial state. Dekho, there is liquid plus vapor. Matlab, is state ka, at this state there is liquid plus vapor. He is asking what is the liquid under initial conditions, what is the liquid, and finally it is saturated vapor. Wonderful, my dear students. ये तो बहुत ही अच्छा क्वेश्चन है. Please tell me, have you followed the question? मतलब क्वेश्चन को समझे या नहीं समझे? So देखो, we are not interested in answer whether you have understood the question or not. There is a rigid container. So there is a liquid vapor mixture in the rigid container. It is heated. How long it is heated? Until all the liquid disappears and just reaches saturated vapor. Galat Prashant. Galat. And he's asking what is the mass of the liquid. Ab dhyan se suno. My simple question is, it is a closed system. Whether it is liquid mass, vapor mass, total mass remains constant. Rigid container, total volume remains constant. So therefore, specific volume is volume by mass. Volume is constant, total volume, and total mass is constant. So throughout the process, either volume or specific volume, both are constants. So can I write the final specific volume as Vg at 50 degrees centigrade? Anyone? Why? Because finally it is on saturated vapor. Clearly problem area. At 50 degrees centigrade, Vg de rakha hai. At 50, Vg is given 0.015. It is 0.015. So my dear students, can I calculate the mass? Can I calculate the mass? Yes, I know the volume. I know the final specific volume. So specific volume is volume by mass. So therefore, mass is equal to volume by specific volume. ध्यान से सुनो. So let me calculate mass. This will give me the total mass. Finally, the total mass is in vapor state. So therefore, M2, I'll write. So M2 is equal to final volume by final specific volume. So therefore, M2 is equal to, whether it is initial or final volume, it will be same. So it is 2. By what is the specific volume? V2, 0.015. Can anyone tell the final mass? Anyone? Excellent. 133.33. Someone gave the answer as 300 and something. Total mass ही 133 है. How can total mass is 133? How can liquid mass be more than this? Definitely it has to be less than this. So if you get more than this, your answer, yes, Prashant, you are right. Prashant, you are right. Prashant, you are right. Prashant, you are right. अब देखो, can I write M1 is equal to M2? Wonderful, my dear students. That is 133.33. क्या मैं V1 is equal to V2 लिख सकता हूँ? Because it is isochloric process, so specific volume is constant. Specific volume is constant. So what is V2? 0.015. But where is initial point? Everyone knows. Initially, it is in liquid state. So therefore, whenever it is in a wet region, it will be Vf plus X into Vg minus Vf. Please tell me, is the question clear? All of you, is the question clear? Initially, it is in wet region. Whenever it is in wet region, I have every right to write this equation. But all of you note down that these Vf and Vg are at 10 degrees centigrade. So therefore, V1 is already known. Anyone, what is V1? Dekho, V1 is either, dekho, all of you, V1 is equal to V2 is equal to 0.015. V1 is equal to V2 is 0.015. That is equal to Vf. Ye sare Vf at 10 degree and Vg at 10 degree. So what is Vf at 10 degree? At 10 degree, Vf. Dekho, saturated liquid is Vf. Saturated vapor is Vg. So therefore, 0.0008, 0.123 plus X into Vg minus Vf, 0.05 minus Vf is 0.0008. Can anyone in the class give me the value of X? Can anyone in the class give me? See, I'm not happy with you. You are just. मैं पूछा what is the value of X? Very sorry, my dear students. I'm very sorry, my dear students. I'm asking you what is the value of X. कैसा वन होता रे? मुझे समझ में नहीं आता क्या students है रे बाबा. It's very sad, I'm telling you. Sorry. So I'll stop taking classes seriously because आप लोग ना, you are not at all serious. My KM students are serious. So therefore it is 0.288. So therefore it is 0.2888. So ध्यान से सुनो. The total mass is 133.3 and the initial dryness fraction is 0.288. Can you tell me what is dryness fraction? Mass of vapor by mass of vapor plus mass of liquid. So 0.288 is equal to mass of vapor by, this is the total mass. MV plus ML is the total mass and that is 133.3. So 133.3. Can you give me mass of vapor? अभी वो भी नहीं देंगे आप. Very sad, I am telling you. वो भी only ताबिश दे रहा है. तारकेश, sorry. 38.47 kg. But is he asking mass of vapor? Is he asking mass of vapor? No, he is asking initial mass of liquid. The total mass of liquid plus vapor is 133.3. So mass of liquid is 133.3 minus mass of vapor. So mass of liquid is 133.3 minus mass of vapor is 38.47. Oh, kitna aa raha hai? 94.8. Prashant has already given the answer. This is the mass of liquid. So let us analyze clearly, my dear students. यहाँ पे initially 94.8 kg liquid था और कितना वेपर था? 38.47 था. And finally यहाँ पे पूरा वेपर 133.33. So this is the problem. Please tell me, is the question clear? It is one of the good questions. हाँ, कुछ नहीं बोल रहे देखो. I'm very sorry with you क्योंकि ना I'm going to give you some lovely questions, but I'll say बैठो आप. Very sad. Shubhra ji, is it clear? Amit sir, is the question clear? Wonderful, wonderful, my dear students. Wonderful students of Rohit Babu. 1 2 3 4 5 6 7 8. देखो उनका नाम देखो. वाह वाह. Take this question. वाह रे वाह. वाह रे वाह. Take this question. Take this question. वाह रे वाह. Take this question. मजा आएगा. Take this. Take this. वाह. Oh, wonderful, Himanshu. Harmanshu या Himanshu? Himanshu. Wonderful, wonderful. God bless you. रिटर्न क्लियर हुआ, इंटरव्यू है ना. हाँ, चलो रीड दिस क्वेश्चन. एक बार ये क्वेश्चन को पढ़ो एक बार. आई रिक्वेस्ट एवरीवन टू रीड दिस क्वेश्चन. अब इस व्हाट अ ब्यूटीफुल क्वेश्चन दिस इज. थोड़ा बुर्रा उपयोग करना. बुर्रा का मतलब तेलुगु में ब्रेन. इंटरव्यू अभी नहीं आया. यस, मेरे केन के बहुत सारे स्टूडेंट्स का क्लियर हुआ. यस, आई हैव पर्सनली कॉल्ड देम एंड गाइडेड आल्सो. हाँ, ये थोड़ा बुर्रा उपयोग करना. थोड़ा बुर्रा उपयोग करना. A piston cylinder arrangement shown in the figure contains air at 250 kilopascal 300 degrees centigrade. Now the 50 kg piston has a diameter and initially pushes against stops. The atmospheric pressure is इतना. थोड़ा दमदार क्वेश्चन है देखो. See, these are all top level questions. थोड़ा बुर्रा उपयोग करना. बुर्रा उपयोग करना. Piston cylinder arrangement contains air at 250 kilopascal and 300. So I write the initial pressure is 250 kilopascal. And what is the initial temperature? 300 degrees centigrade. So first convert in Kelvin. What does 300? Has the session, we have completed one question. So 300 degrees centigrade, इसको Kelvin में convert करना. So it will be 573 Kelvin. Yes, sir. The 50 kg piston has a diameter of, and the diameter of the piston is 0.1 meter, and the mass of the piston is 50 kg. क्या सवाल है बेटा? This is one of the best questions. The atmospheric pressure. Okay. The atmospheric pressure is given as, what is the atmospheric pressure? देखो एक बार. What is the atmospheric pressure? 100 kilopascal. And the atmospheric temperature is, Amit, I think wrong. Atmospheric temperature is 20 degrees centigrade. See here, funny answer, Amit. It is actually cooling down. Its temperature is 300. It is cooling down. Then only it will come down. No, he said when will it begin to? So कब आप हीट करेंगे तो और प्रेशर बिल्डअप होगा. So देखो ये ऊपर जाने की कोशिश करेगा. How can it be greater than 300 degrees centigrade? बोलो एक बार, आप ही बोलो, है ना. हाँ, विल चेक. ओ 183 केल्विन. नो नो, एक बार देखते हैं. प्लीज, दिस इज अ वंडरफुल क्वेश्चन. लेट मी टेक सम टाइम. Okay, the piston, the cylinder now cools down as the heat is transferred to the surroundings. So how can its initial temperature is 300? How can it be more than that? समझ में आ रहा है आपको? How can it be more than 300 degree or 573? Please understand carefully. चलो, at what temperature does the piston begin to move down? Oh, देखो. Let me explain the question. See, if I explain, if you understand such type of questions, then you will not be in any trouble. एक second इधर देखना. Everyone look at. There is a gas initially at a pressure of 250 kilopascal, and its temperature is 300, so 573 Kelvin. Wonderful. Please note down carefully. Understand carefully. एक काम करते हैं. Initially, when this gas is, understand carefully, this 250, so concept समझने की कोशिश करो. When this 250 kilopascal is pushing, there is outside atmospheric air, there is weight of this, of course, and देखो, when the piston is trying to move up, when gas is pushing, stops are also taking. This is due to stops. Now understand carefully. Wah, Amit, wah, 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 Amit. Okay, now understand carefully. अब देखो, थोड़ा क्वेश्चन को समझने की कोशिश करो. Try to understand the question. Initially, please look at me. मेरे तरफ देखो. Initially, the gas is pushing. So that pressure of the gas is balanced with weight of the piston, atmospheric air, and stops are offering reaction. मतलब stops का reaction, weight of the piston, atmospheric. So three put together is 250. Now slowly it is losing heat. The gas is cooling down. So what will happen? It loses the contact. When it is about to lose the contact, now stops का कोई role नहीं है. Yes or no? So it is about, I am telling you, about. So when it is about to lose the contact, what is the volume? I am taking two situations. One is this situation, initial volume. What is initial volume? Area. This piston area into length. How much is this length? 25. Of course, centimeter hai. Whatever it may be. Now, look at carefully, my dear students. क्या concept है देखो. When it is about to lose the contact, अब ये stops पे नहीं आएगा. Can anyone tell what will be the pressure now? What will be the pressure? So stops नहीं आएंगे. Slightly अब देखो. Now I'll draw the figure. Please have patience. Just about to lose. तो देखो. Wait. Stops are not providing. So this pressure is balanced with atmospheric and weight of this. Wonderful, Nikhil Baba, wonderful. So let us calculate that pressure. So this problem has so many things. So about when it is losing the contact, this is initial. So finally what is happened when it is about to lose? There is atmospheric, there is weight, but I'm talking about the pressure. So there is weight mg and gas pressure. So अगर आप forces balance कर रहे हैं, let P2 be the final pressure. So forces balance कर रहे हैं into area. Wonderful, my dear students. Into area. तो क्या होगा? PATM. अरे, all of you are getting? अब when it is losing the contact, about to lose. So please, about to lose, what is this volume and about to lose volume? See, just it has lost contact, so volume will remain same. At that instant, when it is about to lose the contact, this volume will be same, but pressures are not same. Why pressures are not same? Because it is losing contact with stops. When it loses contact with stops, what will happen? Only the atmospheric pressure and weight of the piston will take. Only atmospheric pressure weight. So let me calculate the final pressure. So therefore, P2 into A is upward. देखो, P2 into A is upward is equal to downward. PATM into A plus mg. Weight. ये weight downward atmospheric. So therefore, P2 is equal to P divided with area. My dear students, divide with area. So it is mg by area. So therefore, P2 is equal to, what is atmospheric pressure? Anyone? What is atmospheric pressure? 100 kilopascal. 100 kilo means 10 power 3. Pascal is Newton per meter square. Plus what is the piston weight? 50. G is 9.81. So this will be Newton. This is kg. G is meter per second square. This is Newton. Area. What is the area? Dekho, piston area. Pi by 4 d square, 0.1 square. So this is so many meters square. So you will get P2. Anyone, what is P2? Anyone, what is P2? Kya ho raha, sir? I'm not happy with you. What is happening? 162.45 into 10 power 3 Pascal or 162.45 kilopascal. Wonderful, my dear students. Wonderful. Ab dekho, what is that I'm going to do? Whatever the mass is there, PV is equal to MRT. It is a closed system. So therefore, mass will be, is it correct? mass is equal to PV by RT. Matlab, I'll write PV by RT under initial condition is equal to PV by RT when it is about to fall. When it is about to fall, and you know clearly when it is just about to fall, what is the volume? Anyone, what is the volume when it is just about to fall? When it is just about to fall, what is the volume? ये volume same होगा. R gaya. Wonderful, my dear students. Wonderful, my dear students. So therefore, P1 by T1 is equal to P2 by T2. What is P1? Initial pressure is 250 and temperature should be strictly in Kelvin, is equal to 162.45 by T2. Can anyone tell? Question तो second part का है, एक बार पढ़ो. At what temperature does it begin to move down? क्वेश्चन तो सेकंड पार्ट है ना, फर्स्ट पार्ट ही कर रहा हूं मैं. किस टेम्परेचर पे इट इज अबाउट टू फॉल बोला, अबाउट टू मूव. सो व्हेन इट इज अबाउट टू मूव डाउन मतलब कांटेक्ट इज ब्रोकन. व्हेन कांटेक्ट इज ब्रोकन एट दैट प्रेशर इट विल मूव. प्लीज टेल मी, आर यू गेटिंग? एनीवन विद T2? 372.83 Kelvin. At this temperature it is about to lose contact, about to move down. All of you, are we clear? नहीं समझ में आया? Please tell me, is the question clear? I request. समझ में आया या नहीं है? नहीं है तो we'll stop it. सारांश, is it clear? Is it clear? Yes or no? Very good, wonderful. अब next सवाल देखो. How far does the piston drop from the when the temperature reaches? देखो, please see the question. I request you to see the question. I request you to see the question. Wonderful. Jnana Prakash, देखो, we'll see. What is the initial temperature? Anyone? What is the initial temperature? Anyone? What is the initial temperature? 573 Kelvin. When it is about to lose contact. When it is about to lose contact. When it is about to lose contact, the temperature is 372.83. Now he is asking what distance it is falling. देखो, by what distance it falls. तो initially ये कितना था? How much is this? I think it is 25 centimeter. By what distance it falls so that the final temperature is atmospheric. What is that temperature? 20 degree का मतलब 293 Kelvin. Can anyone tell how do we do this? Very simple, my dear students. Very simple. From this situation to this situation. देखो बार. From this situation to this situation, what is the process? Anyone? What is the process? Now it is a constant pressure process. Can you tell me? Okay, what is the pressure here? Anyone? ये pressure कितना है? Already you know 160. Already you know this pressure कितना है? 162.45. Wonderful, my dear students. Wonderful, my dear students. Wonderful. Or I can write PV is equal to mRT, or mass is equal to PV by RT. So let us equate this mass and this mass. What is the initial pressure? Either I can equate this mass, ये दोनों equate करेंगे या फिर ये दोनों करेंगे. So can anyone tell what is the pressure here? अब pressure क्या है? So it is a constant pressure process. It is a constant pressure process. Therefore, it will be 162.45. So देखो, it is from here onwards. It is a constant pressure process. So therefore, PV by RT in this situation is equal to PV by RT in this situation. This and this situation. Wonderful. So R is gone. Is it clear, my dear students? R is gone. Now देखो, what is the pressure here? Original pressure 250. So therefore it is 250. Can you tell me what is the volume? Area into length. How much is this length? Original length. Area. What is this length? 25. Ariyar, I want this volume. Can anyone tell this volume? Can anyone tell me this volume? Anyone tell this volume? This volume is equal to area. What is the area? A into length. Original length is 25. Very good. Can anyone tell what is the final area? देखो, please listen. So P, what is the pressure here? 250. V. by R T1. What is the temperature? 573. Should be equal to, what is the final pressure? 162.45. And you should be very careful. So both are in kilopascal. Can anyone tell what is the final volume? The final volume occupied by the gas is only this much. क्या कोई बता सकते what is the final volume? Anyone? It is area into this length. Can you tell me this length? This length 25 minus x. 25. बोलो रे. What is this? अरे यार, what is this volume? Anyone? What is this volume? What is this volume? It is area into this length. This length. What is this length? 25 minus x. So therefore, area into 25 minus x. Can anyone tell what will be the unit for x? It is in centimeter, because ये centimeter में है तो ये भी centimeter. And what is the final temperature? It is 293. Area कट गया. Can anyone tell me how much it is falling? 5.32 centimeter. Wonderful question, my dear students. क्या question है रे बाबा? I know you have not followed. Have you followed? क्या question है देखो. What a question this is. See, you are not happy. Is it clear? Is the question clear? आप लोगों को समझ में आ रहा है? Good things must be appreciated always. Beauty not appreciated is a sin. पता है आपको? Beauty not appreciated. If you see someone beautiful, definitely you'll appreciate. है ना? Beauty not appreciated is a sin. याद रख लेना वो. Nature का process है. Beauty not appreciated is a sin. Oh my God, Charan Babu. All these I had explained in my regular class, why it is a constant pressure process. All these I had explained in my regular. How can I take ambient? Who said how can I take ambient? Because my gas, agar ye piston weightless hai, if this piston is weightless, then inside pressure, outside pressure will balance. But this fluid pressure should balance with atmospheric plus weight. आपको समझ में आ रहा है? That's why you should attend all my fundamental classes. So when fundamentals are clear, then only it will be clear. नहीं दिख रहा है दूसरों के डाउट्स? पता नहीं कल से ये क्या हो रहा है? Oh my God, what is happening? कल से ये नहीं दिख रहा है दूसरों के डाउट्स? Oh God. ये भी खतरनाक क्वेश्चन है रे. आज दिख रहे हैं ना? ये भी खतरनाक क्वेश्चन है रे. पहले हल्का सा करेंगे, उसके बाद खतरनाक करेंगे, क्योंकि ना सारे खतरनाक है तो आप भाग जाएंगे. देखो, अब कल देखो आरएसी के क्वेश्चंस देखेंगे. वंडरफुल. हाँ, प्लीज रीड दिस क्वेश्चन. नहीं भागेंगे. ये सिंपल क्वेश्चन ले लेंगे, उसके बाद टफ ले लेंगे. 1 mole, देखो, of an ideal diatomic. Can anyone tell what is gamma for diatomic? It is 1.4, which is 7 by 5. Can I write 7 by 5? Shubhra, it is diatomic, not monatomic. And from 23rd, this course is coming. Okay, 8 a.m. to 10 a.m. Okay, fine. ये प्रॉब्लम कंप्लीट करो. एनीवन? क्या 1.3 होता है बेटा? क्या 1.3 होता है? Be careful. Very simple. He is asking what is the work done by the gas. This is the process. कैसे करेंगे? अरे आप I'll do it. No one is giving. Only Harish Rao Saab has given the answer. So this is the initial point. This is the final point. So therefore, just project. Only Harish Rao Saab has given. इसलिए Harish Rao Saab great है. So initial point को project करना. You project the initial point. You project the final point. So अगर आपको work चाहिए, calculate this area. No one is giving answer. इतना simple question का भी आप answer नहीं देंगे, तो how can we survive? देखो, so let me divide this into 2 parts. This part. Can you give me this area? Length is P naught and the width is 2 V naught minus V naught. So this is P naught V naught. So ये area P naught V naught. Can anyone tell what is this area? Total area will give me what is this area? 1/4 of a circle. What is circle area? Pi r square. देखो यहाँ पे please listen, please listen, please listen. So can you tell me this? ये तो circle है, ये तो circle है. So what is the radius? The radius is 3p naught minus p naught is 2p naught. The radius can also be written as, देखो ये भी radius है. This is also radius. This is also radius. This is also radius. So what is this? 2v naught minus v naught is v naught. So therefore I will write this area as 1/4. Why 1/4? Circle है. तो ये 1/4 of circle है pi r. So answer is given in PV. So what is this length? What is this length? V naught. Radius. Can I write radius as 1/4 pi r into r? Yes, this r is V naught and this r is 2p naught. आप लोगों को समझ में नहीं आ रहा है? All of you, are you getting? All of you, are you getting? अरे यार 1/4 pi r into r. This radius, देखो एक बार. This radius is, अरे नमूने, this radius is 2p naught and this is v naught. So therefore r into r, p naught. Okay, तो ये कितना आ रहा है? This will be 2 कट गया. So pi p naught v naught by 2. So this area plus this area. So this area plus this area. So the total work will be pi by 2 p naught v naught plus p naught v naught, and that will give me the answer B. Please tell me, is the question clear? Is the question clear? Oh, अब पसीना छूटेगा. Now देखते हैं how many of you can solve. अब देखो मजा आएगा. Come on, my dear students. Come on. Can you try? ये तो बहुत ही बढ़िया क्वेश्चन है. It's a wonderful question, my dear students. It's a wonderful question. वाह. Let me do this without Panchamda. Namaskar. Panchamda. A fixed mass of oxygen. Oxygen is diatomic. Oxygen is, अरे यार अगर टाइम देते जाऊंगा तो हमारा देखो it may take a lot of time. Diatomic. Can anyone tell what is gamma? I'll give, but it takes time. Can anyone give me what is gamma for diatomic? 1.4. तो कितना आएगा ये? 7/5. What is the efficiency of the cycle? एक बार देखना. एक काम करते हैं. We'll do one thing. My dear students. Wait. We'll do one thing. Wait. Let us assume that the same question was asked and he's asking us to represent the same cycle on PV diagram. मान लो the same question is asked. He is asking us to represent the same question on PV diagram. This is on pressure temperature plot. तो क्या करेंगे बोलो? Very good, my dear students. Can anyone identify what is AB process? अगर कोई identify करेंगे तो I'll give one chocolate. What is AB process? Very good, my dear students. PV is equal to MRT or P is equal to chocolate कल देंगे MR by V into T. It is something like Y is equal to MX, where M is slope. इधर देखो, pressure is on y-axis, temperature is on x-axis. Okay, so slope is equal to, इधर देखना, slope is equal to Y is equal to MX, MR by V. And can you tell me what is the slope of this? Is it a straight line? Yes, straight line का मतलब slope is constant. ये तभी constant हो सकता जब MR by V is constant. Mass is already constant, R is already constant. Very good, Amit Saw. Very good. So ये तभी constant होगा when it is a constant volume process. So this is a constant volume process. Anyone with BC? यहाँ पे it is on temperature, so temperature is constant. And what is CA? देखो, it is constant pressure. So please आप एक काम करो, you try to represent this on PV diagram. देखो एक बार represent करो. What is A to B? Pressure बढ़ रहा है. Okay. A to B is constant volume, but the pressure is increasing. A to B, it is constant volume, pressure is increasing. B to C is isothermal. So देखो एक बार, what is happening? Pressure is dropping. PV is constant. B to C, PV is MRT. तो ये कब कांस्टेंट, देखो एक बार, what is BC? Anyone? What is BC? Isothermal. Temperature constant. M is constant, R is constant, temperature is constant. So PV is constant. B to C, pressure is dropping. When pressure is dropping, volume should increase. So you know isothermal is a rectangular hyperbola. Pressure is dropping, so volume is increasing. And what is C to A? Constant pressure. Yes, my dear students, this is actually the cycle. This is actually the cycle. Hope you have understood clearly. Hope you have understood clearly. So therefore, let me take it to the next slide. Aram se. Purposefully, I have represented it on PV diagram क्योंकि he may be asking, okay, PV diagram, है ना? Yes, Nikhil, very good. बाबू निखिल, अब देखते हैं, एक काम करते हैं, I'll try to do it on here only. एक सेकंड देखना, I'll try to do it. What is A to B? Constant volume. What is work in A to B? Anyone in the class? What is work in AB? Anyone in the class? What is work in AB? कोई नहीं बता रहा है, मार डालूंगा सबको. Constant volume में वर्क 0 होता है. What is heat transfer in AB? Anyone? What is heat transfer in AB? It is a constant volume process. For constant volume process, heat transfer is change in internal energy. So therefore, it will be MR. देखो आप A to B जा रहे हैं. So therefore, final temperature minus initial temperature. Can anyone? देखो यहाँ तक समझ में आएगा? No. MCV कुछ नहीं बोलते आप. DU is MCV dt. DU is, देखो एक बार, CV is equal to R by gamma minus 1. Or CV is R by, what is gamma? Diatomic. So 7 by 5 minus 1. So you will get CV as how much? Can I write it as 5R by 2? Can I write it as 5R by 2? Yes. So heat transfer in AB is equal to M. CV is 5R by 2. TB. Can anyone tell what is TB? देखो, what is temperature at B? What is temperature at B? What is temperature at B? 3T. A. What is temperature at A? देखो TB, A to B ना, TA. What is temperature at A? It is T. Wonderful, my dear students. So heat transfer in AB is given by, तो ये 3T minus 2T is 2T. 2TA to, देखो 3T minus T is 2T. This two will get cancelled. So it is 5 MRT. That is the heat transfer in AB. All of you, यहां तक समझ में आया या नहीं आया? Till now, is it clear? All of you, till now, is it clear? बोलो एक बार. Till now, is it clear? If this is clear, I'll proceed. If this is clear, I'll proceed. Is it okay? बोलो sir. Now let us go to BC. Can anyone tell what is BC? Isothermal. Oxygen can be treated as an ideal gas. When an ideal gas undergoes isothermal process, what is the relationship between heat transfer and work transfer? इधर देखना. D dash Q is equal to du plus D dash W. Oxygen, ideal gas. So internal energy of an ideal gas is a function of temperature. When temperature is constant, can anyone tell what is this law? Internal energy of an ideal gas is a function of temperature. What is this law? What is, very good. Only Rohit Babu is giving Joule's law. When temperature is constant, internal energy is constant. When internal energy is constant, change in energy is 0. When change in energy is 0, so therefore heat transfer is equal to what? Work transfer. In which process heat transfer? देखो और एक सवाल आ सकता, देखो. See, one more question can come. In which process in which process for an ideal gas all the heat is converted into work? ऐसा question आएगा. It is in isothermal process, but for an ideal gas. So for a given heat input, which process gives you more work? For a given heat input, because in isothermal जो भी heat दे रहा है वो work में convert हो रहा है, but in other process उसमें internal energy में convert हो रहा है. So isothermal process gives you maximum work for a given heat input. You should stress the word given heat input. समझ में आ रहा है रे? क्या नमूने है रे आप भी, वेरी सैड नमूने. ओके, सो हीट ट्रांसफर इन बीसी, वर्क ट्रांसफर इन बीसी. कैन एनीवन टेल व्हाट इज वर्क ट्रांसफर इन आइसोथर्मल? क्या कोई इक्वेशन दे सकते हैं? आइसोथर्मल वर्क एम आर टी एल एन वी फाइनल बाय वी इनिशियल. देखो पीवी इज वेट एम आर टी, isothermal temperature is constant, PV is equal to mass is constant, R is constant, temperature is constant. Mass is constant, R is isothermal temperature is constant. So can I write P1 V1 is equal to P2 V2? Can I write? Or P initial V initial is equal to P final V final, or V final by V initial is equal to P initial by P final. Wonderful, my dear friends. What is isothermal work? MRTLN V final by V initial. Okay. So heat transfer in BC is equal to work transfer in BC MR. Can anyone tell what is the temperature in BC? क्या कोई बता सकते what is the temperature in BC? देखो B और C का एक ही टेम्परेचर है, B और C का एक ही टेम्परेचर. Anyone what is the, I am talking for BC. For BC what is the temperature? For BC what is the temperature? It is 3T. Don't get confused with T. MRT मतलब उस प्रोसेस का टेम्परेचर. So MRT for BC what is the temperature? For BC what is the temperature? It is 3T. MRT log. Can I write V final by V initial as P initial by P final? Wonderful, my dear students. So heat transfer in BC is equal to work transfer in BC is equal to 3 MRT log. B to C के लिए, B to C के लिए what is initial? B is initial मतलब 3P. B to C final is P. So I will write this as heat transfer in BC is equal to work transfer in BC is equal to 3. Sorry, क्या क्वेश्चन है रे बाबा? I am very happy. 3 MRTLN PP कट गया 3. All of you, is it clear? All of you, is it clear? कुछ नहीं बोल रहे. देखो, is it clear? If this is clear, then I'll proceed. If this is clear, I'll proceed. Now let us go to EB हो गया BC. Wait. Let's go to, all of you are following, my dear students. All of you are following. Very good, Prashant. So Prashant, आप थोड़ा टाइम ले रहे लेकिन सही दे रहे. अमित so already he gave. AB हो गया, BC हो गया, CA. CA is a constant pressure process. Work transfer in constant pressure. Can anyone tell what is the work transfer in constant pressure? ठीक है रे बेटा निखिल, आप महान है रे बेटा, आप महान है रे बेटा, आप तोप है रे बेटा, आप ग्रेट है रे बेटा, और क्या है रे बेटा, यू आर टॉपर बेटा. ओके, व्हाट इज आइसोथर्मल वर्क? प्रेशर इनटू V final minus V initial. Is it correct? Is it correct? Yes. Work in CA is equal to PVF minus PVI. देखो work in CA. Can anyone tell what is PV? MRTF. PV initial. MRT initial. So work in CA is equal to MR को बाहर ले लेंगे. What is? देखो C to A. For C to A, this is initial, this is final. C to A, the final temperature is T. MR तो बाहर गया, initial temperature. C to A, for C to A, this is initial, which is 3T. This is final, which is T. So the initial temperature is 3T. Can anyone tell what is work in CA? Minus 2 MRT. What does negative sign show? Can anyone tell what does negative sign show? Anyone? Work is done on the system. Wonderful, my dear students, wonderful. Now let us calculate heat transfer in CA. क्या कोई heat transfer in CA दे सकते मुझे? मैं बताऊंगा. देखो heat transfer in CA is equal to, बोलो रे, देखो du dw. Ha. Yes, you are right. MCPDT. So in a constant, yes, wonderful, my dear students. Wonderful, my dear students. Heat transfer in CA. CA is constant pressure. MCP. What is CP? Gamma R by gamma minus 1 into T final minus initial. C to A. Final is T. Initial is 3T. All of you, is it clear? All of you, is it clear? C to A heat transfer is constant pressure. M, this is CP. देखो एक बार MCP dt. What does dt mean? dt मतलब C to A. ये final है T, initial है 3T. देखो एक बार, gamma is 7 by 5. Gamma R by gamma is 7 by 5 minus 1. Gamma R by gamma minus 1. So how much is this? Anyone, how much is this? 7 by 2 R, correct now? So therefore, CA heat is equal to M into 7 R by 2 into, बोलो रे, कितना रहा है? कितना रहा है? कितना रहा है? Minus 2T. So therefore, heat transfer in CA is minus 7 MRT. Wonderful, my dear students. Wonderful, my dear students. Wonderful, wonderful, wonderful. So, okay, है ना? एक सेकंड, लेट मी टेबुलेट. एक सेकंड रुको, एक सेकंड रुको, प्लीज स्टॉप. क्या स्टूडेंट्स है रे बाबा? वेरी गुड स्टूडेंट्स ऑफ इंडिया. नो 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 नो, डल स्टूडेंट्स ऑफ इंडिया. पूरे डल स्टूडेंट्स ऑफ इंडिया. आई नो यू आर ऑल डल स्टूडेंट्स ऑफ इंडिया. करेक्ट और रॉन्ग? करेक्ट और रॉन्ग? यू आर ऑल डल. यस बोला देखो. ए बी, बी सी, सी ए. Oh, no, 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 no. You're all dull students. What is AB work? AB का वर्क क्या है? 0. AB का हीट 5 MRT. BC वर्क हीट 3 MRT ln3. 3 MRT ln3. 3 MRT. मैं भी आपकी तरह डल हूं. करेक्ट ना? What is CA? minus 7 MRT. And what is the work? Minus 2 MRT. Wonderful, my dear students. Wonderful, my dear students. Wonderful, my dear students. Wonderful, my dear students. देखो देखो, see the beauty, my dear student. See the beauty. अगर आपका कैलकुलेशन सही है या गलत है, यहाँ पे पता चलेगा. For a cycle, sigma q should be equal to sigma w. Whether you have done this correctly or not, check करो, add करो, add करो. तो सिग्मा वर्क कितना आ रहा है? टोटल वर्क 3 MRT. अरे 3 MRT ln3 minus 2 MRT. एक्सलेंट. अब व्हाट इज सिग्मा क्यू? देखो ये ऐड करो. देखो 3 MRT ln3. If you are adding, देखो ये तो हो गया. So 5 minus 2, 5 minus 7 is what? Minus 2. वाह, मतलब they are equal. My problem is solved. अरे यार, are you getting, my dear students? All of you, are you getting? So can anyone tell what is efficiency? Net work or sigma W by heat supply. क्या कोई बता सकते what is the heat supply? Can anyone tell what is the heat supply? Can anyone tell what is the? Purposefully I have done this question. Do you know why I have done this question? Why I have done this question? आपको पता है? क्योंकि different processes, different heat transfers, different work transfer, सारे इसमें आ गए. देखो, that's why a single question is giving most of the things. What is heat supply? देखो, ये नेगेटिव है heat rejection, पॉजिटिव है heat supply, पॉजिटिव है तो heat supply. Can anyone tell what is the total heat supply? Total heat supply is this plus this, so it will be 3 MRT ln3 plus 5 MRT. Correct na? Correct na? Correct na? बोलो sirs, बोलो रे. Okay, so what is the efficiency? Network sigma W. Network is sigma W. देखो 3 MRT ln3 minus 2 MRT by heat supply 3 MRT ln3 plus 5 MRT. So I think I can cancel out MRT. So 3 ln3 minus MRT कट गया. MRT. So 3 ln3 plus 5. So anyone got the answer? What a beautiful question. There is no doubt about it. There is no doubt about it. Yes or no? आप कुछ नहीं बोलते, ऐसे ही बैठो. दूंगा है, आप सब लोग दूंगा है. आप सब लोग दूंगा है, दूंगा. यस, ऑल कॉन्सेप्ट्स इन वन सिंगल क्वेश्चन. एक से बढ़कर एक देखो, एक से बढ़कर एक क्वेश्चन है. लेकिन आप लोगों को क्या चाहिए? इधर देखो, मैं बताता हूं. इफ आई टेक अप सच, ये नहीं देखेंगे हाउ टू गेट single digit rank in 30 days. Oh, everyone will go and see. When your teacher is giving conceptual questions, ये है अपना हाल आजकल ऑनलाइन का. ओ प्रशांत, बी केयरफुल. The problem is how to prepare for GATE. My experience. Oh, 1 lakh views. And when I give such questions, 3-4 लोग देखते हैं. That is the state. That is the state of आजकल ऑनलाइन का जमाना है. Yes, true. True. And when I give some stories and tell, whoa, आ गए. Now, I am going to give you one question as assignment. So now we have 5 minutes. So now you have 5 minutes. Now please, 5 minutes, ये क्वेश्चन करो, देखेंगे. 5 minutes, ये क्वेश्चन करो. And I'll tell you very clearly, isothermal. This is also isothermal. Up karo. And this is constant pressure. It is given constant pressure. Karo dekhenge. During the cycle, it's not process. What a beautiful question. ये भी मतलब ideal gas है. Yes, it is an ideal gas. It is an ideal gas. Of an ideal gas. Of an ideal gas. अब time waste मत करना, आप करो. It is an ideal gas. Yes. Yes, it is an ideal gas. And even if it is not given, if it is not possible to do the question, you can take ideal gas and proceed. अब मैं करूंगा. My simple question to you people is, he is asking, what is the heat absorbed by the gas during the cycle? Means complete cycle mein how much heat? Please note down that it is internal energy versus pressure. For the first time we are seeing this. Okay. Can I write, देखो एक बार, the temperature of gas at C and D. At C, the temperature is given as 300, and at D, the temperature is given as 500 Kelvin. देखो एक बार, what is A to D? What is A to D? Isothermal. Isothermal. So can I write this as temperature at A also equal to yes? Similarly, anyone, what is the temperature at B? Anyone, what is the temperature at B? Temperature at B. B and C is isothermal. एक काम करेंगे हम, एक काम करेंगे. I'll do one thing. I'll do one thing, my dear students. Have a look at this. He is asking sigma Q. If I calculate sigma W, will it be same? He is asking total heat transfer during a cycle. So let me calculate total work. Will it be same? Will it be same or different? अरे यार क्या हो रहा है? So it is a cycle, so therefore it will be same. So let me calculate net work. So let us calculate work in AB. Let us calculate work in AB, my dear students. अभी फटाफट कर देंगे. We'll complete this. We'll complete this. Let's calculate work in AB. How do I calculate? What is AB process? What is AB process? AB process. बोलो AB. AB is constant pressure. Correct ना? A to B is constant pressure. So work is pressure into final minus initial, correct? So work in AB is equal to PV, देखो PVF minus PVI. So work in AB is equal to, what is PV? N R bar T final minus PV can be written as N R bar. देखो, this is initial. Wonderful, my dear students. Wonderful. PV is NR bar T initial. So I will do like this. Work in AB is equal to NR bar ko bahar le lena, T final minus T initial. So work in AB is equal to, how many moles are there? 2 moles. R bar. What is final temperature? A to B. A to B means TB minus TA. TB is 300 minus TA. What is TA? 500. So I think I'm getting work in AB as anyone. What is the work in AB? It is 200 minus 400 R bar. Correct now? Correct now? Similarly, can you calculate? And I want the answer. And if I do that, I'm leaving this as an assignment. Will you try? I'm leaving this as an assignment, and you should get the answer as 400 R bar ln2 और ये solve कर लेना. Okay ना? चलो, we'll meet tomorrow with either IC engines questions or cycles. It is a bit different. Yes, it is a bit different. You need to practice. So hope you have enjoyed the class. So tomorrow we'll meet again at 6:30. Yes, it may be IC engine, it may be Brayton cycle, it may be Rankine cycle. It all depends. Or it may be RAC. So I'll combine thermo applications. Okay. Thank you. Thank you. Thank you. God bless you. Again, I have a class. Came class.